In this video, we're going to take a look at implicit differentiation. Up until now, you have found derivatives of functions where, for example, you've solved for y in terms of x, and so you've found dy dx. Sometimes it's not convenient to solve for y, and we'll take a look at that. But in this example, 2x squared plus y squared equals 4, if we wanted to find the derivative, we would solve explicitly for y. So y squared would equal 4 minus 2x squared. We would isolate y with the positive or negative square root of 4 minus 2x squared. And then we would be able to take the derivative. So dy dx would be equal to positive or negative 1 over the square root of 4 minus 2x squared. Don't forget to multiply by the derivative of the inner function, which is negative 4x. So in effect, we get positive or negative 4x divided by the square root of 4 minus 2x squared. Okay. Sometimes it's not convenient to solve for y in terms of x, or it's just plain difficult. So here's an example, y cubed plus 2y minus xy equals 7. That's not easy to solve for, and so we're going to implicitly differentiate. So here's what we do. We assume that y could be solved in terms of x. Not that I'm going to do it, but we assume that it could be. And we treat y as a function in terms of x. Then every time we take the derivative, because y is a function of x, we have to apply the chain rule. So in this example, if I wanted to take the derivative, I would say 3y squared is the derivative of y cubed, but y is a function in terms of x, so I'm going to also multiply by the derivative of y with respect to x. All right, the derivative of 2y would be plus 2 dy dx. The derivative of x times y, well, I must apply the product rule. So x times dy dx plus y, the derivative of x with respect to x is 1, equals 0. Okay, so there's the derivative. It doesn't look pretty, but what I could do is I could isolate all these terms that have dy dx in them and solve for dy dx. Okay, so dy dx times 3y squared plus 2 minus x would equal a positive y. I've distributed the negative and moved the y to the other side. And then solving dy dx would be equal to y over 3y squared minus x plus 2. Okay, that was a little bit quick, and we're going to take a look at what we're really, we'll take a look at summarizing those strategies in a bit. Okay, so when we look at implicit differentiation, first, check to see if the variables agree. So for example, if I want to take the derivative of x cubed with respect to x, well, my expression x cubed is in terms of x. I'm differentiating with respect to x, and therefore the variables agree, and I can just use the power rule. So 3x squared. Okay, if the variables disagree, so if I have the expression y cubed, but I want to differentiate with respect to x, then here's where I must apply the chain rule. So I'm using the power rule. The derivative of y cubed is 3y squared, but then I'm multiplying by the derivative of y with respect to x. That part I've applied the chain rule. Okay, so let's take a look at this problem. We have y squared minus 2y plus 3x equals x squared. So if I treat y as a quantity in terms of x, then taking a look at the first two terms, I'm differentiating with respect to x, but I have a y squared term. So the variables disagree. The second term, I'm differentiating 2y with respect to x. The variables disagree. In that case, I must apply the chain rule. So the derivative of y squared is 2y. The derivative of y with respect to x is the factor I use when I'm applying the chain rule. Derivative of negative 2y is negative 2. Since y is a function in terms of x, I have to multiply by the derivative of y with respect to x. All right, the last two terms, 3x differentiated with respect to x, that's just applying the power rule. I get 3. And the derivative of x squared with respect to x is 2x. Okay, what I'm going to do now is I'm going to factor the dy dx terms from the left-hand side here. And so, well, actually, I guess moving over here, we are going to isolate those dy dx terms. So let's move the 3 to the other side. We get 2x minus 3 on the right. Then let's factor the dy dx from 2y minus 2. Then we'll isolate dy dx by dividing by 2y minus 2. And so here's the derivative of this function with respect to x. All right, so some guidelines for implicit differentiation. Differentiate both sides of the equation with respect to x. Collect all terms involving dy dx on one side, and all other terms move to the other side. Factor the dy dx out of the terms on the one side. Solve for dy dx by dividing both sides. So just back up to part 1 here. When it says differentiate both sides of the equation with respect to x, in the case of an expression in y, apply the chain rule. So you will have a factor of dy dx. Okay. All right, we're going to take a look at some examples and practice implicit differentiation. Okay, number 1, y cubed plus 7y is x cubed. Differentiating 3y squared times dy dx plus 7 times dy dx is equal to 3x squared. Factoring dy dx from the left-hand side, we have a factor of 3y squared plus 7 equals 3x squared. Dividing by the factor to isolate dy dx, we get 3x squared divided by the quantity 3y squared plus 7. All right, number 2, we need to apply the product rule to the first term. Okay, I'm going to factor out that 4 and apply the product rule to x squared y with leaving that coefficient outside. So the derivative x squared times dy dx plus y times 2x. The derivative of negative 3y is negative 3 dy dx equals 3x squared plus 0. Okay, now I will distribute that 4 to the quantity x squared dy dx plus y 2x. So that will be 8xy plus 4x squared dy dx minus 3 dy dx equals 3x squared. All right, factoring and isolating. So 4x squared minus 3 times dy dx will equal 3x squared minus 8xy. Isolating dy dx, we get 3x squared minus 8xy all over 4x squared minus 3. Okay, a few more examples. X squared plus 5y y cubed equals x plus 9. Differentiating, we're going to get 2x plus 15y squared dy dx equals 1. Isolating the dy dx term, 1 minus 2x is equal to 15y squared dy dx, and isolating dy dx, we get 1 minus 2x divided by 15y squared. All right, number 4. Differentiate y with respect to t. Okay, so derivative of t cubed, 3t squared, plus, here we're going to need the product rule. So t squared dy dx plus y times 2t minus 40y cubed dy dt equals 0. Isolating the dy dt terms, or at least grouping them, and factoring out the dy dt, okay, and moving the other terms to the other side, we're going to get minus 3t squared minus 2ty. Okay, dividing by the factor, negative 3t squared minus 2ty divided by t squared minus 40y cubed. There's a lot of negatives in that expression, so I might choose to write it as 3t squared plus 2ty over 40y cubed minus t squared. All right. Last question. Find the equation of the normal line. The normal line is the line perpendicular to the tangent line. Remember, perpendiculars have negative reciprocal slopes. Okay, to the curve 8 quantity x squared plus y squared equals 100 x squared minus y squared at the point 3, 1. Okay, so first thing, let's find the derivative, and we need to find the slope at 3, 1. This derivative looks a little messy just to start here, so we're going to get 16 x squared plus y squared to the first power, but then I must multiply by the derivative of the inside, which is 2x plus 2y dy dx equals 100 times 2x minus 2y dy dx. Okay, we've got to distribute and isolate. So on the left-hand side, I'm going to have 32 x plus 32y dy dx. I move that 16 into there. And then x squared plus y squared equals 200 x minus 200 dy dx. Okay, again, I've got to distribute this. So 32x x squared plus y squared plus 32y x squared plus y squared dy dx equals 200 x minus 200 dy dx. Let's move the dy